Okay, live streaming on.
So yeah, oh yeah, okay, now it works. I don't know, totally random. I'm not sure what's going on. Okay, so I am posting in the chat the link to YouTube in case anyone would like to watch the presentation on YouTube rather than on Zoom. So we have that, and let me just, okay. And so then I can go ahead and share screen and we will get started. Okay. That. Oops. All right. Welcome everybody to the last day, day number 11 of May Institute on Computation and Statistics for Mass Spectrometry and Proteomics. I am very happy that so many of you are back with us on the last day, that you are not too exhausted. I'm also happy to have an opportunity to talk about a very, very important topic. So a lot of the discussion so far has been oriented more around using software or using statistical or data analysis tools for various purposes. And today, last but certainly not least, we will have a session which is dedicated more to people who actually write their own code, and specifically write their own code in Python, because it is really important to develop tools and software in ways which are scalable to beyond one data set and one particular analysis, but the tools that can also be used to reproduce the analysis later on, and can also be used to share not just the analysis results, but the code itself. And so I'm really, really happy to introduce our speaker and our instructor today. So Charlie Hoyt has an undergraduate degree in chemistry from Northeastern University. So I'm really, really happy to have this connection. We actually didn't know each other back then, but I'm really happy to have a fellow Northeastern graduate with us. Charlie went on and received a PhD in computational life sciences from the University of Bonn in Germany. And Charlie is actually joining us from Germany right now. So even though Charlie is in Germany physically, he is a postdoctoral research fellow in the Laboratory of Systems Pharmacology at Harvard Medical School. And Charlie's research covered the interface of biocuration, knowledge graphs, and machine learning in systems biology. And Charlie made many important contributions as an advocate to reproducible research. And so I'm really, really excited to have this opportunity to share this discussion with all of us as part of May Institute. So before we move on, and if you are just joining us, let me go over some logistics, which will be somewhat different from the previous sessions. So usually we use the chat for things such as, hi, how are you? Or we can hear you, which happened in the last sessions. And we use Q&A for questions related to the actual science of the presentation. Now, because we're a smaller group and because Charlie is a very interactive person, Charlie actually wants you guys to speak. So whoever would like to actually have voice privileges or even video privileges or share screen or anything like that, please raise your hand or put a message in the chat, and we will be promoting you to presenters anytime throughout this session. However, if you prefer to stay kind of, in the background and just ask questions and typing, so please do that. Please use Q&A box. So we have Sarah, Vartika, Sai, and Rohan, who are PhD students in computer science, who are joining us also as co-panelists. They will be monitoring the Q&A, and they will alert Charlie if there is a question that needs to be addressed for everybody. So please don't hesitate to raise your hand or request participation vocally. Otherwise, we will just proceed as in the past. So Charlie will be live coding, and this will be a lot of fun. So I very much look forward to that. Thank you so much, Charlie.
All right. Thank you. I just realized that I've been sending messages in the chat, not to everybody. So I was making jokes about happy hour in Germany too. It is indeed happy hour In the United States, they say it's 5 o'clock. Somewhere in Germany, they say kein Bier vor 4. It's basically the same idea. It's always a good time to drink. So welcome to my presentation. Today, the topic is on making your code that you write as a scientist useful, reproducible. There's a third word. I don't know what it is. Reusable, reproducible, useful. Yeah, 3 words. We're going to do everything in the service of these. And today we're going to basically go through from 0 to a lot. I'm going to walk you all through something. I'm basically going to do a lot of live coding. We're not actually going to be writing so much Python code. We're going to be writing a lot of the configuration that goes around Python code to make it really easy to use. So the first thing I'm going to send into the chat one more time is the link to the document that's outlining the tutorial we're going to be doing today. I've given this tutorial several times, and I've taught lots of people with varying degrees of experience in Python programming or programming in general. Even if you're not using Python as the primary language, a lot of the concepts we're going to talk about today are relevant for every language and for all sorts of different kinds of analysis and kinds of science that you're doing if it involves a programmatic aspect. So yeah, first, is everybody able to hear me okay, see me, and am I speaking too fast already?
All good.
All good. Okay, so I can see that a couple people have already found their way into this this Google Doc, and so yeah, for me, it's totally fine. There's 28 people in the presentation right now. If you want to join as a speaker and just kind of chime in, or if you want to write some stuff in the chats, like Olga said, the other panelists will just ping me because I'm going to get super into stuff, and yeah, once I start talking, I might never stop. So we're going to have a break in about an hour and 20 minutes. Halfway through the middle, so everyone can take a breather, get some water, and yeah. Anything else before we launch off into the beginning of a journey together? So
far, so good. We'll keep you on track.
So yeah, I guess I better start by thanking Olga for inviting me to do this, and the Calgary College of Computer Science for putting on the May Institute, and I guess they're funded by the NIH and Chan Zuckerberg initiative. So thanks for everybody for putting this together and giving me the chance to give you guys some of the knowledge that I find super, super important, and I'm really excited to share it with you. All right, I think we're ready. So I'm going to hit screen share, and we're going to start a project together, and I'm going to walk you through how I put together a Python project and how I make it useful for all sorts of different kinds of things. So let's do it. All right, here we go. Every project that I start usually starts with the repository on GitHub, so I'm going to do that. I spend a lot of time on GitHub, and I'm always making new projects for things. So here we go, new repository. I'm going to walk you through creating a very simple package that does something very simple. I haven't decided what to call it yet, but the idea is it's going to help with expanding URLs and making them go from a short form to a long form. Anyway, the point of this isn't super important, but I need some inspiration. So let's call this simple resolver. Okay, good. I'm making a repository on GitHub. I'm making it public. I'm going to put a README in there just so I don't have any problems. And then I'm going to create the repository. So if everybody is not familiar with GitHub, definitely check this out. This is a place where you can share your code with other people. But more importantly than sharing it, GitHub is a version control system, and it's built on top, GitHub is built on top of a version control system called Git. And what this does, imagine like you have some code in a Dropbox folder, and every time you hit save, you just make a little note, hey, this is what I changed since the last time I saved. So version control is really helpful because you can see exactly what code looked like at a certain time in case it changes later. All right, so we're gonna make a repository in GitHub, and that's where we're gonna put our code, just like a folder in Dropbox. So here we go, create a repository. And now I've got a repository, I've got a very short README, and the next step after I've created this on GitHub is actually to clone it. So I have a program called Github Desktop set up. Github Desktop allows me to sort of interact with GitHub on my local computer. So I'm gonna press the big green code button, I'm gonna open this in Github Desktop, and this is gonna do the same thing as cloning the repository and pulling it. Now, I'm not a huge fan of Git, to be honest. It's a very complicated program, but we only need to do very simple things most of the time, which is like committing files to the repository, pushing them from my computer onto the GitHub system, and then double checking if anybody is collaborating with me that they've made some changes. I'm going to pull it back. But we don't have to do that because it's just me right now. So here we go. I'm going to clone this. All right. So now it's in my computer. Next step, I'm going to go ahead and double check that that's in the right spot. So now I'm in my terminal. All right, so there's not much going on inside my repository already. I've got a README file and I've got a .git folder. This is the configuration that Git creates. We don't have to touch
Charlie,
that.
could you clarify? So would you like everyone to do the same or just follow along for now?
Yeah, so that's a good clarification. Thanks. I wrote that down. I've given this presentation before where I had people follow along and do every step at the same time, but there's actually so much stuff that it might be a little bit difficult to follow along. So I'll invite people to give it a try, but I'm probably not going to stop periodically and wait for people to catch up, because at some point, if you fall behind, then we won't be able to finish. So, we're going to have a recording of this. All of the steps of what we're doing are kind of written out in this Google Doc, and I've got blog posts about each of these things and lots of links to other resources if you don't like the way that I do the writing. So yeah, try your best to follow along if you're interested. Otherwise, just like sit back, enjoy the ride, and learn a couple things, and then you can come back here and find the right links and the right resources at the end. The other good thing is every change that we make, every step that we take is going to have its own commit inside this Git repository. So you can always go through and look at that commit history and see how the files changed over time yourself. So we've already
yeah, there's a question. Can you say a few words about GitHub? So for someone who is not.
What else can I say about GitHub? Well, so there's the Git version control system. GitHub is a website built on top of it. It's basically the total standard for people sharing their code. So let's check out a collaboration I've done with Olga's group called Bell to SCM. And this is a place where we decided to dump all the code for some analysis. We did structural causal models on biological systems. And so we've got all sorts of stuff inside this repository. There's some configuration, there's some like Jupyter notebooks. Maybe you're familiar with Jupyter notebooks as a way of like organizing your code. There's some like data, there's some, artifacts that we generated, like, PDF files that have charts that we created. So basically, you can have kind of any files in here, and GitHub also has a file browser. And then all these READMEs, they get formatted nicely to help you navigate and understand what's going on. Yeah, so there's a lot to learn about GitHub. We're not actually going to be focused so much on this other than it's like a tool that just kind of helps us do our work. Again, just think of it like a glorified version of Dropbox. It's useful for people who are writing code. It's actually really good to start your project on GitHub and periodically commit your stuff to it rather than just waiting until it's done and then dropping it all there. Okay, let me double check. It's in the chat. Is this a 3-page? Okay. Good. Then I guess we're going to keep going. So here we go. We had this open, we had this open, and then I was in the command line. Okay. So the thing that I think is a difficult aspect of Python programming, and actually all programming languages, is how do you organize your code in a way that is standard so other people kind of know what to expect, and so it can be run using the tools that exist in the language already without doing anything tricky and complicated. And it turns out that as you learn how to program in Python or R or any languages, you actually don't learn so much about what are these practices, which sometimes they have a scary word associated with them called software development or software engineering. And I know that turns a lot of people off in the beginning if you're a scientist. I mean, I'm also a scientist by training, right? So, I didn't take, I don't have a degree in computer science. And even if you have a degree in computer science, you don't necessarily focus on software engineering as a discipline. So all of us are learning this sort of on our own time, and you're here and we're going to learn a little bit about this together. So I just want you to know that you're going to be a software developer at the end of this, even though you don't really think you are. So I've given this talk several different ways, and in some times that I've done it, I've started from absolutely nothing in this empty repository and built up everything we need one file at a time. It turns out that it's very difficult to stay on track with this sort of thing. And so I'm going to do it the opposite today. What we're going to do is we're going to basically create the entire package. We're going to create all of the stuff that we need using a template. And we're going to go in and fill in all the stuff that we need. And then I'm going to explain what all of the parts are. And so you can all actually follow along with this quite easily. So one sec, I'm going to check the Q&A. The screen that you are in, what is it? So this screen that I'm in right now is a command line. And so this is the way that you can sort of access the file system programmatically. And it has lots of tools inside it. You know, it has like echo, and it has cow say. This is super important. Yeah. And yeah, so this is sort of a minimum requirement. I think that you should be able to open up the command line and do some of these things. This is also a place where you can like run a Python program. So I don't have a Python program right now, but yeah, so every computer has one of these. If you're on Windows, it's called command prompt. I think you can use that. I would suggest if you're a scientist, get off of Windows. It's got a lot of problems for programming. But anyway, all this stuff is still possible. I don't have time to explain how to do this in every system. So, you know, on the Mac, open up your terminal. On Linux, it's also like called the terminal somewhere. Okay, so what we're going to do is we're going to first, so everyone should have Python installed. So we're going to do Python -m pip install cookie cutter. All right, so yeah, Python's this commands. If you use -m, you can basically run a module, and pip is the module that installs other things. So we're going to install a package called cookie cutter. The job of cookie cutter is to create templates and to help us use templates. So I've already prepared a template that has all the stuff we're going to talk about today. And so I've installed cookie cutter, and now I'm going to run cookie cutter. So yeah, I've already got an autocomplete on here. Basically, I have a package on GitHub called cookie cutter snack pack, which is my template for Python packages. So basically what we're going to do is we're going to instantiate this template. We're going to go through them. I'll explain all the parts of it. And hopefully we can do that in about an hour, maybe an hour and a half. And then the rest of the time we have together, maybe we can try looking at some of your own scenarios. So without further ado, I'm going to basically run this cookie cutter. So GH means like GitHub. I could also have written out the https://github.com/, but this is just a shortcut. So we're going to do this. It says you've downloaded this. You want to re-download it? So yes. Now it's going to ask a couple questions. So what's the name of this package? So this package is going to be called the simple resolver. And to stylize the package, I'm going to write it like this. So the first one needs to be like a valid Python package name. So it should have like underscores instead of spaces. It shouldn't have dashes in it. Shouldn't have any numbers in the front. It shouldn't have any trailing or leading underscores. You know what Python packages usually look like this. It's called kebab case. And then package name stylized. We can actually write it out with like normal looking letters. A short description. This expands and contracts queries. Okay, we don't have to know what that actually is. All right, it lets you put in the author name, so I have it default to me. You should put your own name, email address as well. GitHub organization, yeah, so this is your username on GitHub, and then GitHub repository name, that's the name of the repository I made on here. So it's almost the same, but it has a dash in it instead of a underscore. And typically with URLs, you use dashes, but Python packages use underscores. So just keep that in mind. All right, do I need a command line interface? Yes, sure. All right, good. So now I'm going to open up the Finder. And so basically what just happened is it made this, sorry, I know this is a little bit small, but it made this folder called Simple Resolver, and inside it is everything I need for the package. So what I'm going to do, I'm going to copy everything, including the hidden files, out of this folder, and I'm going to put it in the folder one level above, and I'm going to replace the old README. Okay, so now I've got all sorts of stuff going on in here. I'm going to go back to my GitHub Desktop. GitHub Desktop now shows me the diff. This is all the things that have changed since the last time that I saved my GitHub repository. So you can see all these green pluses mean new files. Yellow squares means a modified file. So you can see the green lines are the new lines, the red lines are the old ones. Yeah, and so it's added all sorts of stuff. It's added some badges. It's added some information on how to install the code. We're going to get to like how all this works. Basically, I'm going to already make a commit. I'm going to say initialize package. So quick question for everybody. Is the text too small on my screen? Are you able to read this, or should I make the text bigger?
Looks reasonable on my screen.
Okay, good. All right, so now I've got the code here. Navigating through the file browser isn't so great, so I'm going to open up Pycharm. This is an integrated development environment. Pycharm is free for students. You can download this using your university or like academic institution email address. I would highly suggest it. It's a great piece of software for organizing your code. And no, so it works for Python. It also works for other programming languages. So I'm going to go ahead and open up this project that we just created. Yeah, and now this is a little bit better way of browsing it. So for Pycharm, the first thing that I want to do is I want to look at the source folder, and I want to note that this is going to be where my code goes. So I'm going to right click on that, mark the directory as sources root. Yeah, I'm going to try and keep the Pycharm stuff like as minimal as possible. This is basically one of the only settings. All right, so we're going to jump back a little bit. We're going to go to the web browser. So before this web browser just had this simple readme. I'm going to refresh this because remember we just committed that code and pushed it to GitHub, and it should show a lot of new stuff. So we see all the same files are here. Now we've got some of these badges. We've even got some information about getting started. This template says, hey, you should fill in this template once you've written some code. It has some information on how to install the package now. I'm going to get through like explaining how all this stuff works, but basically it's all ready to go. The packages also have a little bit of information about contributions, though typically as a scientist, other people won't make any changes to your code. You might just want to use it. Another important thing is licensing. So when you write code, you have sort of rights to the stuff that you create. Depending on the way that your appointment works, you may also need to license the code to the institution that pays you. But typically as scientists, this isn't a big deal. You can just write your name as the person who licensed it. So understanding a little bit about software licensing is a good place to start today. And so we're going to go to a website called choosealicense.org. Okay. Now it's .com. Okay, so yeah, when you give other people code that you've written, you actually should write a license for it. And so there's a couple ones that are basically the easiest ones to use. And so one of the ones that I use all the time is called the MIT license. And the idea here is that if people can use your code, they can kind of redistribute it, they can change it, but they should attribute you when they use it and when they change it. This is kind of what we expect as scientists. Like, it's not the same exact thing as they should cite you, but if they're redistributing the code, they should basically say that it's from you, and they should say what the changes they made are. So this is the best one maybe for scientists, something like the MIT license or the Apache license or some of the GNU, GPL v3 license. So we're not going to go down that, but sometimes you really want to make sure that everybody's forced to share the code again in an open source way. So anyway, you can think about that. MIT is basically the best way to go. So that's the one that's already in the repository template. All right, so I'm going to start walking you through all of the files that are in here, what they do, why they're there, and how we can basically use them. So let's go back to Pycharm. Let's close this README. So the first thing I want to show you is the source directory. And inside the source directory is the same name as the package that we're working on, simple resolver. And so basically the way that we want to make our Python code is we want to give it a package name. This is super important, right? Like you're importing all sorts of packages that are great, like NumPy and Pandas and Seaborn. And so if we want to be able to import our code, we have to give it a name. And so I gave it simple resolver. So inside the source folder, we make another folder with the name of the package. And then that's where we put our code inside there. So the first thing you notice is there are actually some kind of funny looking Python files with these underscores. So I'm going to open up this one. And so when you see 2 underscores in the Python world, you actually pronounce that as dunder. So this file is called dunder init. So it has double underscore init, double underscore. And every package should have one of these double underscore init files. And this basically tells everybody, hey, look, this is packaged code. And there isn't really anything going on in here. Right now, it's basically just, it's done some imports from some other files, and it's got a doc string, and it has a little bit of information about the encoding, but this isn't like strictly necessary. So let's double check inside this API.py. So if you use this template, basically the way that you can use it is you open up your template and you can just copy all your code into this api.py file. You can write some stuff that does this and that, and then you can basically start reusing it. So I'm going to write a very little amount of Python code. And so what was this package supposed to be? Yeah, so all right, so I'm going to write some Python code that does some stuff. And so we're going to go for key value prefix. Okay, I think we're done writing Python code for today. So I'll explain what this does in a little bit, but I also want to illustrate how is the best way to explain what your code does through this process. So yeah, oh, it's not contact, it's contract. So the idea in the semantic web world is sometimes you have like, sometimes you've got some function, you've got a prefix map. Let's say that inside your prefix map is, so Kibi. So Kibi is a way of naming chemicals. And sometimes you have URIs that describe like biological things. Sometimes you want to turn those URIs into a short form. And so the idea is you might want to use what's called a prefix map to contract your URIs. So if I have a URI that looks like this, that describes a chemical, and then I have my prefix map, basically what I want to do is get back a short version of this. Let's say, let's implement this differently. Okay, so here we go. We basically take a URI, and anytime the URI starts with one of the things that are values inside my dictionary, I basically want to get rid of that first part, and I want to put the key that's in the dictionary in its place, and then separate it with a colon. And this is like a super useful thing I spent every day thinking about how to do this kind of string processing. So that's why we're using it as the example today. Yeah, and so maybe I should write this. Maybe you notice that I've kind of written what's called a doc string. And so when you have a Python function, if you use triple double quotes in the first line of your function, you can start writing documentation. Typically, the way people write documentation in Python code is to have like a one sentence explanation. So contract a URI into a query. Yeah, so people write documentation like this. Typically, they use a very specific kind of language as well. So the way the sentence is written, it's actually like a command. It's in the imperative mood, which means like, imagine the way you write doc strings is like you're yelling at the computer to do something. Computer, please contract a URI into a query given the prefix map. Yeah, and so we should write it this way because everyone writes their code with documentation that looks like this. And one of the recurring things that we're going to talk about a lot today is that you should just always do things the way everyone else does them because it reduces the burden of other people who are reading your code. And I know I haven't like stressed this point a lot, but when you write code and you publish it as a scientist, you know, code is your methods section of your paper. And so you should imagine other people will try and read and try and understand your code and then eventually try and use it. And all those things are important. So it's part of the scientific process. It's part of the publication process. It's really your responsibility and your duty as a scientist to document things and make them understandable. So anyway, now we're figuring out how Python kind of looks. And so, notice that like my IDE has already done some nice highlighting because it turns out that if you want to give some examples of your code, how to use it, you can use these triple greater than signs or chevrons, you know, to basically write some code inside your doc string. This code doesn't get executed like code that's inside your Python file, but if you can basically do some other interesting things that we'll come back to. Okay, next step in writing good documentation is we're going to say something about each of the things that go into the function. So it turns out that if you do this special form, you do a colon, you write param, and then the name of the parameter, then you go into the next line, you can sort of describe this. So, a URI or URL to contract. So yeah, we can explain what each of the things inside the signature of the function are. So we can do the same thing with prefix map, a mapping from as short. Okay, so I've written my two inputs, and then I can also say returns and say kind of what the output is. So a contracted URI query I'm going to change the implementation now because I think the way that I implemented it was not very smart. Okay, so it's going to contract the URI if it can, otherwise it's going to return it. So, okay, we're basically done writing Python. So maybe you're not really familiar with like why you'd want to do this sort of thing. But anyway, so like this is the code, and now we want to share it with people. So first of all, we can write lots of code, and sometimes we want to tell people what parts of the code we really want people to be able to use. So sometimes you have some functions that are just for you. Some of the functions you might want other people to be able to look at. So sometimes you might see this thing, which is called dunder all. And basically what dunder all does is it lists all the things that other people should be able to look at. So we're going to say the name of the function contract is one of the things that people should look at. All right. Next step. All right, so we've written a function, we've documented that function, we even gave some like examples of how the function is used. And now there's one other thing that maybe you're not aware of if you're looking at Python before. You can actually add some information about what kind of values should go in and out of all of these. This is kind of, I'm going to gloss over this. It's kind of advanced, but I think it's nice because it helps you write good documentation. And so the URI is typically a string. So in Python, strings are like instances of this str thing. So if we do a colon after the name of the input, and then we put str, now Python knows, hey, look, this should be a string that's going inside. And a prefix map, this is a dictionary where the keys are strings and the values are strings. And so this is how you annotate that. I'm going to double check in the Q&A for the current one. Okay. Yeah. And the last part is what comes out of this function. Well, the thing that gets returned is also a string. So then you use this this right arrow chevron. So note that I've got font ligatures on, but typically, this is like these two characters. All right. So this is all really useful. Imagine that doing this kind of annotation helps other people understand your code better. Now, you don't have to do this. And not all code is so easy to annotate with types. This is a lot of stuff to learn. So if you want to know more about this specifically, you can look up something called MyPy. So that's MYPY. You can, and an optional static typing. So this is like really, really interesting. It's pretty high level. So I'm not going to say any more about that right now. All right. In the Q&A, somebody asked. Okay. So next step. Basically, we've got, all the code that we're going to write today. And now the question is, how can other people use this? Like, when you're writing Python code, you typically do something like this. You do import numpy as np, and then you do np.zeros. Hold on, my computer's getting a little slow, so I'm gonna wait for it. Oh, I don't think I have NumPy installed in this environment. Okay, we're gonna go back. Are there? Sorry, I keep seeing stuff on the Q&A popping up. Okay, next step. So we've written some code. Now we want to make sure that people can use it. So the first thing we're going to do is we're going to look into this. What are we going to do first? All right. So we've got our source folder. We've got some code inside this. Note that we didn't really talk about these other ones. They're just going to sit there for now. We'll come back and explain what they do in a little bit. The next thing we want to look at are these files, the pyproject.toml and setup.cfg. These are very scary sounding file names, I agree. And they're the ones that contain all the information that tells Python how to install the code and how to reuse it. So people can use pip to install your code. And so we're going to open those up. We're going to look at all the bits inside them. I'll explain what they do. And then, yeah, then we're going to basically show that we can already install this code and use it. So first step, let's open up setup.cfg. So I'm going to go from the top to the bottom, just explain these lines one at a time. I think everything's pretty self-explanatory, but you have to know what this stuff is. You have to, well, okay, so you don't have to remember all of it by heart. I actually don't remember all of it by heart. I just kind of reuse the same stuff every time. So in the beginning, we're using a CFG file. So if you've never heard of that, CFG files typically have these headings inside square brackets, and then they have like lists of some keys with an equal sign and then some value that comes after. So it's like a two-level dictionary. All right, so we start with this metadata heading. And inside the metadata, we need the name of our package. So simple underscore resolver, that matches up to the same thing as the name of the package inside our source folder. Next, we should give our package a version. And you can see that the template's already filled in all this stuff for us. So we're going to start with version 0.0.1-dev. This is about as low as it gets. That's fine. We can actually call it whatever we want here. But there's a couple tools that I'm going to show you that maybe even help you deal with this versioning thing. Maybe for a lot of code that you write, you might want to just call it like version 1 and like that's it. And that's okay too. Next thing is we're going to give a short description of the package. So I wrote this back in the beginning when I was in the command line. So this package expands and contracts queries, like good enough for now. And now the next thing is the long description. And this is actually kind of cool because basically it reuses the README. And so this kind of magical file colon thing says, please use the README when you're distributing this. And actually what happens, let's say you go to the website PyPI. You've probably used pip to install things, and PyPI is the website that actually shows the information about the packages. So here's like when you pip install NumPy, here's the website that actually describes that. And so this thing that's in project description, that's what would be the long description of your package. So let's say for a package that I write, it's a much more interesting long description than NumPy's, the bioregistry. So this has, you know, some information about downloading and contributing, and all of it's already inside. Okay, so back to the code. So we've got our long description. Now we're going to add just some metadata. Like this is super useful, but you know, not every project puts this stuff, so it's good to just know that it's there. So first of all, the URL to where the code is. So this is the GitHub repository that you put it in. And then the download URL, the bug tracker, the source code, these are all based on like this, the URL for the GitHub repository. So we could kind of move on. Information about the author. So that's like your name and your email address. Like I wouldn't worry too much about putting your email address here. Like I don't get a lot of spam, even though I put my like personal email address and everything. And super tangent from already a very tangential sort of talk. Don't ever use your institutional emails for this stuff. You should use your personal email because you will leave your institution and you will not take that email with you. And you'll miss out on all sorts of really interesting stuff when people actually want to get in touch with you. So yeah, use Gmail. Don't use your Northeastern or your whatever. Okay, then there's also the maintainer. Typically, this is like the same person. But sometimes, you know, someone writes some code and then at some point they give it to somebody else to take care of. This is not super common that it's different in science. It's like kind of just one person. All right, next line is the licensing information. So we already said like we're picking the MIT license by default. I'm going to actually open up that file and briefly show it to you. So here we are, MIT license, very short legal text. It already filled in my name here. I filled in the current year. And then here's the text for it, which you can try reading yourself, but it kind of does what I said before. It asks people that if they use this, they should kind of attribute you, and you're not really responsible for like if they hurt themselves using your code. So that's good. Probably don't write code that helps people hurt themselves or other people. Yeah. So in the license, basically this thing right here says MIT license. That's actually from a controlled vocabulary called the software. I don't remember. It's called SPDX. So it's just a list of like what the names of all the licenses are. And then license file, is called license. That points to the file license, just so everything's all attached to each other. Okay, next. We can actually gloss over these classifiers and keywords. They're basically just ways that people can search for your code and a little bit of structured information about the code itself. So let's say like in the keywords, you might, like if you're a biologist, you might put biology, or you might put, mass spec or computational proteomics or something like that. I don't know, whatever your package is about, you can add your own free text keywords, right? There's a couple to-dos scattered throughout this template of stuff you're going to need. All right, the next section is the options section, the options header. And this is really, really important. Now this answers the question, what do people need to install with pip ahead of time before they can use your code? And so I have a couple opinions on code that everybody should be using, but you're going to probably want to put your own requirements here. So typically people are using stuff like, so let's move these around. We don't need any requirements now, but this is a place where you might write NumPy. Maybe you're using pandas. Maybe you're really fancy these days and you're using like Torch, PyTorch, or maybe you're using, I don't know, Dask, some really cool data processing libraries. So this is where you would write down that list. This is the only place in the package that you need to write down the list. A lot of people are pretty used to writing down stuff like requirements.txt files or creating these awful looking conda configurations. You don't need to do any of that if you've got this. So this is better, it's simpler, and it's more portable for other people. If you have stuff like conda configurations, then people really can't reuse it so easily. Even though a lot of the times I think people do think that conda makes things reproducible. It's not really the case. All right, so I'm gonna leave a couple of these things in here, but we don't technically need them. All right, next, it's time for the hand waving part of the talk. So here's some random options. So zip safe should always be false. You don't need to know why, it just should. Include package data equals true. Like also just leave this how it is. Here's the Python requires. So if you're using features from the newer versions of Python, you should tell people like, hey, this doesn't work on old versions of Python. All right, and here's really the hand wavy part is like, where's my code? Here's the configuration that it's worth copy pasting every time. And basically what this configuration does is it says, look, we're using a standard Python packaging layout where there's a source folder, and inside the source folder is the name of my package. And that's where you need to look. And that's what these 5 lines or 6 lines, 7. Yeah, that's what all these lines do. Always use these exactly how they are. Don't touch them. All right, the next one, we're going to skip this because we're not going to need any extras for now. We're going to skip this one too. We're going to skip this. We're going to skip this. We're going to skip, I think we're going to skip everything. Yep, we're skipping everything. Okay. Now, we've used cookie cutter. I know we're about an hour into talking with each other. Oh, actually, we're not so far. 45 minutes. We've written a function. We've sort of organized it. We've looked at some totally crazy, arcane-looking configuration. And now it's time for us to actually install the code and show that it works. So we're going to come back in here. And we're going to realize that there's some problems, and we're going to sort of get rid of all that. We're going to start over. All right. So I'm going to change back into here. I'm going to create a virtual environment. You don't necessarily have to do this. But I like to use virtual environments to make sure that my requirements all do exactly what I expect them to. All right. So by the way, while that's preparing the virtual environment, I'm actually going to get rid of, never mind, I'm going to leave them. Okay, so I think everyone's pretty familiar with doing something like pip install a package, and then you sort of hit enter, and then it contacts this website we just looked at. It downloads the package, it installs it. It's giving us a little bit of a warning right here. This warning isn't super important. It's just saying, hey, you're using an outdated version of pip, so why don't I just upgrade my version of pip so it stops giving that warning. Okay, so again, we're inside this directory. That's where all of our code is. And so let's like look at all the files in here. Remember, this is like, you've got these setup configurations, you've got some like Some other files we haven't looked at yet. We've got some license information. We've got the README. We've got our source folder. It's time to install the code. And so the way that you install code that's in a folder that you're in right now inside your command line is you do pip install dot. And rather than saying the name of a package you want to install from PyPI, dot says, hey, use this directory. We're already in a place with code. Please install that. And it's going to do the same thing that it normally does. It's going to prepare some stuff. It's going to, install all of the requirements. So here's more iter tools, more click, and TQDM. Those were the ones in the list here. Excuse me, jumping back and forth. All right, and so now it's successfully installed click, more iter tools, excuse me, and simple resolver -0.0.1 dev. So here's our code. Now it's time to fire up Python, and we should be able to get that code now that we've installed it and we've packaged it. So what we do to import our code is we can do import simple resolver. All right, good. We didn't get an error. This is a really good, good start. Now, we have to learn a little bit about how packages work. So I think you're all pretty familiar with doing import simple resolver. And then let's say there might be some code inside it, like simple resolver dot, my function, and maybe you run the function. So this is how you're doing a lot of Python stuff. But we don't have a function called my function. We have this function called contract, and it's inside a submodule called API. So let's jump back really quick to the IDE. So inside our folder structure, we basically got a Python file. And so if we want to look at the code inside this API Python file, we can go back and we can do this. We can do import simple resolver.api. And now we can do simple resolver.api.contract. And if everything works, this we didn't call the function, I just grabbed it. So it's saying, hey, look, you're looking at a function right now. And so if we want to actually run this contract function, maybe I'm going to copy paste some of the stuff from my example. And again, excuse me, jumping back and forth. So we've got our prefix map, and then we've got our contract function. And if all goes well, it's going to output the thing we expected, key B1234. All right, so what happened? I tried running contract, but we actually didn't import contract. We imported it through simple resolver.api.contract. And good, it actually runs and it does the thing it's supposed to. So for the most part, we've successfully written some code. We packaged it using this template, and now we've installed it and we've imported and we've used it. So this is like a huge win. It took us maybe 45 minutes together to get here. But once you know how to do this, you can do this relatively quickly and start putting your code into this place. Let's do a little bit of cleanup now, because this isn't so great, right? So maybe we want to do something like from simple resolver.api import contract. So maybe you're familiar with imports in Python, how this works. So if we do that now, this other way that I wrote it is going to work properly. Good. But this .api thing kind of doesn't make any sense. Like, why do people need to know that there's this .api thing? Why can't I just do simple resolver.contract or from simple resolver import contract? Like, why can't I do this? Oh, I can't do that. Okay. Well, that bad demo. I didn't prepare this properly. So let's try this again. You know things are going bad in a demo when you expect it to go wrong, but it goes right. So we're going to start this tiny part of the demo over. So we're going to fire up Python. We're going to import simple resolver. And then again, I sort of ask, like, why can't I do simple resolver.contract? And it says, hey, attribute error, simple resolver doesn't have an attribute contract. So like, first of all, what's an attribute? And second, like, why not? So basically, the thing that we're going to learn about next is what this init file does, this dunder init file. And so basically, dunder init let's jump back here in case you forgot where this was. That's this file right here. One of the other ones sitting inside the package next to the API.py. And so basically what happens when you import Simple Resolver itself isn't a Python file. It's a directory, excuse me. And so inside that directory, there's a dunder init.py file. And so when you import Simple Resolver, it actually looks at this dunder init file and it says, hey, I'm going to import that. And so right now, there really isn't anything going on in here. By the way, just to prove that this Simple Resolver is actually just a nice facade for this init file, I'm going to actually introspect on this doc string. So you see this expands and contracts queries. That's the same thing that was inside the init file. All right. So basically, the init file does a couple things, but one of the best things that we can do with init is to organize our code and to make it easier for people to access some of the nitty-gritty details. So let's say that what we do inside our init file is we import the contract function out of API. So we do from .api import contract. Funny how the inflection changes the meaning of the word. Okay, so let's just look at the anatomy of this for a second. If we're familiar with imports in Python, you know that you can do from some module, import something inside the module. But here we've got this funny dot right here. So when you're in a Python package context, the dot means, hey, inside the same directory that I'm in, so this init file is right here, inside the same directory is another file called api.py, which we have. We already looked at that. And now I want to import some stuff from that. And so here we go. We import the contract function, and now we're sort of good to go. So let's close this Python. Let's open this Python back up. And now let's try doing this one more time. Okay, so great. Now that we've added this kind of import thing, now this contract function is also living inside init.py. And now it's available for us to grab here. Now let's do one other thing that we kind of forgot about from last time is we maybe are going to import lots of things in here. And just to be really careful, we're also going to do this dunder all. And we're just going to make a list of the things that we really want to make sure that people can grab, just in case. Again, this is like not strictly necessary, but it helps people understand what's going on and why it's going on if you're familiar with like what this looks at. Okay. So until now, we've like made a package. We've put some code inside it. We have now looked through the configuration that it takes to set up that code. We've used it to pip install the code. We've sort of gone and tried how we can actually interact with the code and how we can organize it a little bit using the init files and the API files. So I think we're actually in a really good position right now, because if you're a scientist, this is almost all you need to make your code reusable. From a very like superficial standpoint of reusable, like people can install it on their system and they can like get the parts of the code that you use. Of course, there's more, but you know, this is a really good first step. And if you're this far, you're already in a really good shape. So again, for a lot of you, if you're just doing this for the first time, you're going to want to look into this and say, hey, I've got all this code that I wrote. Maybe it was in a Jupyter notebook. And I'm going to take that code. I'm going to put it inside this api.py file. And typically, yeah, I don't have a demo for this, but if you're writing code inside a Jupyter notebook, it doesn't live inside functions. Typically, we're going to want to put our code inside functions so it can be reused, because the stuff that goes into the code maybe is like a different file, a different piece of data. And then the stuff that comes out is going to be different as well. So that's what we're going to use functions for. All right, so let's sort of take the next step. Let's look at pyproject.toml. So I think that there's one other bit to the setup configuration that I sort of glossed over inside this. So there's 3 lines inside this file that you need that are super important. So it's the build system, and then the requires, and then the build backend. You don't have to know really what these things are and how they work. In fact, there's already a link here in case you do want to learn more. But basically what this does is it says, I want to use setup tools, which is like the simple version of installing Python packages built into Python. Well, kind of built into Python. And yeah, so once you have this, you're good to go. And then these other pieces of configuration are for other stuff. Okay, Next step. So this is, now we're going to go into software development, like hardcore software development worlds, because sometimes you write code and you actually want to test that that code does what it's supposed to do. And remember, we already wrote this sort of almost like an implicit test where we showed like with some input data and some output data, or with some input data, we get sort of an expected output. But, you know, we want to make sure sometimes that our code does a lot of different specific things. So I want to show you how to write tests for your code using sort of the Python style of writing tests. Now, the good news is the template's already taken care of a lot of this for us. It's created a tests directory. Inside the test directory, it's already given us sort of an example, very trivial test. So we're going to open up this test version. And I'm going to walk you very quickly through how this looks and how to use it. So inside this Python file, this isn't part of your package anymore. This is going to import code from your package typically. And it's going to also use a testing framework. So I'm going to give the example with unit test, but there's a lot of different ways to do this. Anyway, the same ideas will be applicable for all the different frameworks. So there's also things called PyTest and nose and so on. So basically what I do is I'm going to create this class called test version. And it actually inherits from this other class, which is called a test case. Basically what this does is it makes this class know that any function that starts with the word test is got tests inside it. All right. So yeah, once we have this function that has some tests inside it, basically we can just start writing code and we can check that that code does something in particular. So let's basically delete all the stuff that's in here because this, you know, this test is sort of trivial and boring. Okay, but before we delete it, let me explain what's going on here. So there's a function that's already created inside this package template called getVersion. And the job of this function is to just return a string that is the version number of this package, which remember is 0.0.1-dev. So sometimes it's useful to be able to get the version of the package directly. And so this test is basically saying, run that function, store the result of that into this variable called version, and then it's going to run this function, self.assertIsInstance version str. Basically what this says is we want to check that this variable version contains a string inside it. Now, you can write this a different way. Python also has a language feature called assert. And then like you do assert and then put some expression here. So the other way of writing this would be to use the function isInstance. And then maybe you're not familiar with instance checking, but this is just like the thing that allows you to look inside a variable and ask, what are you? So these two lines are effectively equivalent. However, the second one, it uses self. Now, if you're not familiar with this part of Python programming where you've got classes, self is a reference to the object that you're inside. And this object inherits from this other class, which already has some functions inside it. And one of those functions is called assertIsInstance. And it effectively is exactly the same as this line. It has a couple extra things that we don't need to worry about. But anyway, we can basically write tests however we want. And we can either use assert or we can use some of the functions built into unit test case. So let's write another test. I'm going to group it into a different class, though you're free to kind of do test, you know, something else. You know, you can put multiple tests into the same test case. You can make multiple test cases. This is going to be up to you. But I'm going to write another less trivial test. Let's call it test contract. Unit test case. I have to inherit from this, and I'm going to do test key. So yeah, I'm skipping a little bit of doc strings here. But anyway, I've got this test function, and now I have to put some code inside it. So I actually want to just reuse this test that we wrote before. I'm going to copy paste all that code and I'm going to massage it until it looks right. So the first thing is we have to get rid of these chevrons because we're actually just running Python code inside here. And then I guess we want to store this as like result. So yeah, remember contract actually returns this value. And then we want to check that it's equal to this. So let's do self.assert equal. All right, so I know that now you're actually getting a lot of Python code thrown at you, but this isn't really Python programming. This is just knowing how some Python libraries work and what to do with them. So we basically run our code here, and then we use assert equal, which is the same thing as writing assert and then using the equals operator between these two things, right? So again, either of these are okay, but I like the first one because it gets some extra stuff. Yeah, so we forgot something though, because there's this contract function, we actually need to import it. So remember, we did from simple resolver import contract. We use that in the command line. We can also use that inside this Python file. Okay, so the great thing is because we're inside an integrated development environment, it's already saying, oh, look, I can tell you're writing tests. Do you want to run the tests? And these little green arrows are popping up. So I'm going to say, yeah, let's run those tests. So let's see if this works. I think it's going to fail. And I think it's going to say, hey, you didn't install simple resolver. So stuff is happening. It's confused. And this is actually a really good jumping off point to the next part of the talk. So we've got, I think about, oh, no, it worked. This is nice. Okay. So it ran the tests and it found they all did what they're supposed to. So that's good. But let's show what happens if you write a test where it doesn't do what it's supposed to. Let's say I'm actually supposed to do keybe with capitals. Okay. So this is going to give a different string than the one that we expect because I've changed the input data. So let's run that one and let's see what happens. Okay, wow, okay, it gave us lots of information. It said, hey, look, this one failed. And it says, here's the string that you got, here's the string that you were expecting, or here's the string you're expecting, here's the string that we got. Yeah, and so it's giving some feedback, say, hey, look, your implementation's wrong. Maybe you wanna go and fix something. Now, we engineered this to fail because we put the data in wrong. The realistic scenario when you're writing tests is that you understand how the code should work, but you don't know if you implemented it correctly. And this helps you to encode that in more code and then, to be able to check. The even better thing is once you have tests for your code, you can be a little more confident if you ever have to update it, that you know that it still works properly. And writing unit tests is not the glamorous part of being a scientist, right? We're already like 3 levels removed from the glamorous part of being a scientist and publishing in Nature, for example. But this is how we make useful and reproducible and reusable science. And if you want to publish in Nature, maybe you don't have the same incentive structure. So let's bar that whole philosophical discussion about publishing and let's just keep doing really good stuff here. So notice that I'm living in my Python IDE right now in Pycharm, and I pressed the nice green button and it managed to run all the tests. And remember, Charlie from 2 minutes ago wasn't even sure this was all going to work properly because he forgot how these environments were all installed. It turns out that, even though your code is packaged and you've got tests, communicating how to actually run the tests or how to run the code is kind of difficult in certain situations. And so we're going to add one extra layer of reproducibility on top of the fact that we can package our code. We're going to write reproducible ways of using that code. And we're going to demonstrate that on how to reproducibly run the tests that use the code. So think about the tests as like a downstream user of your code, and that they're not necessarily part of the code itself. So first of all, let's delete this failing test. We don't actually need that one. Yeah, and so now we're going to look at the next file that's kind of living in this list of funny looking files, and it's called talks.ini. So as I open this, note that it's a very scary looking file full of all sorts of stuff. We're going to kind of zoom in on specific parts of it. So I'm going to scroll down a little bit. We're going to look at this. All right, so again, the idea of talks is to kind of write some reproducible ways of running your code in different scenarios. And the scenario we're talking about right now is running unit tests. Another reproducible scenario that you might want to do is like, how do you actually run the code on your data? For example, maybe you've also got the data in a directory inside your project, and you want to make sure that people run the code exactly the way you expect them to. This is maybe another place where you could use talks. But anyway, let's start with the tests. And we're going to have to learn a little bit about what talks does and how it does it, and sort of check into some of these parts. So as the documentation says, the point of this kind of test env thing, by the way, this is another configuration file, just like setup.cfg. Interestingly, the extension on this file is ini, but it's still the same format. It's still, you've got these square bracket headers, and then you've got some key and an equal sign and some values. Now, it turns out that you can actually put multiple lines of values. We didn't use that before in setup.cfg so much, but we do use it here. All right, so what's actually going on? We're basically running the tests, and we're doing it in a super, super convoluted way. So I'm actually going to delete all of this. All right. So to run the tests inside the tests folder, basically you can run this program PyTest, and then it looks inside it and it sees, hey, look, you're using unit test. Remember unit test? And then it sees there's some functions that have the word test in the beginning, and it finds all of those, and then it runs all of them. So in the background, Tox is nice because Tox knows that the tox.ini file, it lives in the same folder as a Python package. And it knows to install the code in the same folder, sort of before it runs any of these commands. So basically the order is you run this Tox environment, and then it installs the code, just like we did in the command line before with pip install, whatever. And then it runs PyTest. Now, here's the problem though. How do you know that PyTest is available? So it also has some other stuff. And so that's what this extras is. And extras is a little bit of a convoluted way. So let me write this a different way first. So this way of writing it now is deps. This is another list of extra dependencies that your code doesn't actually need to run itself, but the environment that runs the tests needs them. So think about it this way. You need PyTest to run the tests, but you don't actually need PyTest to use your package. So we're going to add some extra dependencies just for this run. So the new order is first, install the package. Second, install everything in this dependencies list. And the third, run all these commands. So how do we actually run this? Let's go back into our command line. Let's exit the Python REPL. So the first thing that we need to do before we use Tox is we actually need to pip install Tox. Now, this may be a little bit antithetical to all the things I was talking about because we don't want people to have to manually install some stuff. But since Tox is a very common tool for automating stuff, you can just kind of assume that people have Tox installed. And so now what we're going to do is we're going to run Tox. It's also, when we pip install Tox, we get this command in the command line for free. And so what we do is we run it with -e and py. And so what this does is it says there's an environment inside our configuration called py. And so, basically py is the special environment that you can either write the name of the environment directly or you can just omit it. I know this is a little bit confusing, so why don't I leave it explicit? So yeah, we've got test env. We can put lots of different test envs, and then they can have colons after them, and then you can have the name. So all this is going to get run when I do tox-e and then the thing after the colon. So let's run it. So now look at what it's doing. It's installing all of the requirements that are necessary to install the package, which are setup tools and wheels. Now it's installing the package itself, and then it's installing the dependencies. Oh, sorry, it's doing that in the other order. First it's installing the dependencies, and then it's going to install the package itself. You can sort of disregard all of this text. Don't worry about this. Okay, so great. Let's double check. So first thing, it installed the dependencies that we need to install packages, so kind of meta. Then it installs the things that we explicitly said in the Tox environment. And then it installs the actual package itself here. And then it runs this PyTest tests. And now you can see it ran 3 tests in 0.04 seconds. And it succeeded, and it gave us a smiley face. Yay. All right, so yeah, now we've sort of reproducibly run our tests, which, like, I guess at this point seems kind of like boring. Okay, fine, you wrote some tests and you ran them and they don't really do anything, but at least this is like the structure for it. So let's double back to this thing that I changed. Originally this said extras and then tests. So it turns out that maybe rather than making this tox file full of all the information about what you need to install it, maybe we can more reproducibly keep track of the kinds of things you need to run your tests. So let's backtrack into another file where this configuration actually lives. So now we're back in the setup.cfg file, and I glossed over a couple things, like for example, this options.extras require. And basically what extras require means is you can list different groups of packages that might be useful for some non-core features or some extra features of your package. So one example is I made a list of all of the code, all the packages you need to run the tests. So originally this was PyTest and coverage. Now I simplified the way that the test running was, but originally it used coverage as well. You can see in this list, there's also a list of all of the packages we need to build the documentation, which we're going to get to after the break. And then there's nothing else here, but other packages that I've written have all sorts of different kind of extras depending on what sort of functionalities you might need that not everybody uses all the time. Okay, so this is the name of the extra, tests. And now back in talks.ini, that's the extra here. So basically this says check in setup.cfg for this extra. This one has PyTest and coverage. Cool. Okay, I'm going to stop here. I want to give everyone the chance to write stuff in the chat, in the Q&A. We can chat a little bit, and then in like 6 minutes-ish, or whenever this chat dies down a little bit, why don't we take a break for maybe 15 minutes? So yeah, who's still with me? Like you can maybe stick your hand up, write something in the chat, just say hi. Am I going too fast? Are you totally bored with this and want to see something specific? I know that we've got this list of all the possible topics in the Google Doc, but you know, every time it's a little different. So what are people saying? Olga says good. Silas says a little bit lost. So I can try and help you get unlost. I know that we're going very fast and we're talking about totally wild new things you've probably never seen before. So if you can describe a little better, like if there's something that you missed or just in general, then let's say that, yeah. So the good news is if you really want to learn this stuff, you can rewatch this video. I can link everybody at the end to other recordings of me giving this talk in different ways. So maybe just today it didn't work for you. And then I also have links to all sorts of the resources where I learned all of this stuff, from reading various blog posts, watching some videos from other people who really, really care about Python programming. And yeah, those would be good places to look at this kind of stuff if you want to hear it from a different person and a different perspective. Okay, and Olga says, let's make a recap. So far, what have we done? We started the day with sort of the goal to learn a little bit about how to make our Python programs more reusable, reproducible, and ultimately useful. And we want to do that because we're scientists and we're using code to help us do our jobs, to investigate various parts of the universe. And a lot of us aren't trained as programmers, and we're doing this. We either learned as hobbies or sort of on the job. And maybe while we did this, we didn't learn the best practices. So that's kind of what we're starting with is we've got some code and we want to figure out how do we organize this in a way such that it's the best for other people to look at, maybe even reuse. So to actually do that, we started by using a template that basically sets up the structure for how we should organize our packages. We use that to create a demo, which is called the simple resolver, that does something that isn't super interesting, to be honest. But yeah, so we put a little bit of code inside this package. We put this on GitHub. We've made a little bit of work with GitHub where we commit this stuff. That's not really the focus of today, but using GitHub is really important, I think. Yeah, and so after we made our package with the template and we put some code inside it, we learned a little bit about how the structure of that package looks and where we're supposed to put our code, a little bit of specific stuff about Python and like maybe the dunder init file, what this does. And then we looked into the configuration that's necessary to take this standard package structure and make it possible to pip install it. The same way we pip install stuff like PyTorch and NumPy and pandas, and then gave a little bit of a demo on how we could get that code that we'd written inside our package and use it. So you can think like, maybe I write some code in a packaged format, then I import it in my Jupyter notebook where I do my heavy analysis with it. Yeah, and so we did that, and we showed that we can kind of get our code, we can implement it, we can organize it a little bit so it's looking nice and easy to import using this init file again. And then we built on top of that, and we said, all right, we know how to write code and import it. Why don't we write some tests to double check our code actually does what it's supposed to? And then we used unit tests to write some of those tests. And then on top of that, we use talks to create a configuration to reproducibly run those tests. Now, looking forward, there's a lot of different directions we can go. One thing we can talk about is continuous integration, which is like pretty next level. So I think maybe we skip that today. One thing we can talk about next is using command lines. So you can make your code that actually does something a little bit more reproducible. We can talk about documentation and some of the configuration that's already built in that's going to help us turn this documentation we wrote inside our code into some websites. Like, you've probably read documentation before for other packages. And so this is kind of the same sort of thing that they do. We're going to do it for our code. What else have we got that's living in this? We've got all sorts more configuration to talk about. I think we can sort of open that up to see what everyone's interested in. And then, yeah, if we've got time, then we can maybe do some practical stuff if some of you have some show and tell. So here's an esoteric question from Mark. Why is Python so heavily used in mass spectrometry versus Java or some other language? That's a really excellent question, Mark. And the same question could be sort of rephrased for a different scenario. Why is the R programming language so heavily used in microarray analysis or RNA-seq analysis? And there's just all sorts of different kinds of answers for this. It just happens, I think, that people working in mass spec like Python and maybe the really powerful tools that people are using these days. I'm not like super familiar with them myself. So even though this week and last week have been about a lot of this stuff, like I'm not an expert, let's say. So anyway, it just turns out that people are interested in these topics are using Python right now. And why are the microRNA packages all only in R? Because they were developed 15 years ago, and the companies that made them were using R. And like that was what people were writing. And so there's no like really good answers other than the second part of the question was like, why not use Java? Java's the worst, and it's really hard to learn, and it's really hard to read, and don't use Java. Sorry, it's a very hard line perspective. Java's got all sorts of really useful software written in it, but it's definitely the case that it's not approachable and it's not so easy to use as Python or R. And so if you're a scientist who's got to learn how to program to do the job, like use a programming language that's easy and gets the job done without thinking too much about this other stuff. All right. So Aaron wrote in the chat, it would be helpful to see links to any resources, especially for learning reproducibility and readability of codes. So first thing I can do is, you're already listening to me, so I might as well do a shameless self-promotion. I read about this stuff a lot on my blog, in addition to other things that might make your eyes glaze over. So you can look through for some of the posts that I've written about Python programming and packaging and reproducibility. And a lot of those have references to resources that I've read. Another place to look, let me get a link for this, is I've sort of collated this list of the best Python programming talks. And this isn't just on packaging and reproducibility. Some of it's also on thinking about writing algorithms and about just like programmatic thinking. And so this is like a playlist of the best Python talks from organized from most beginner to most expert from beginning to end. So you can look at that and learn some things. And a lot of them are short talks, like 20-minute talks. Some of them are longer ones. Like I definitely have sat through a 3.5-hour talk on how to hack the import system in Python. And it blew my mind. And after that, I sort of like started seeing things differently. So if you've got 3.5 hours and really want to blow your mind, try looking at something from David Beasley. Yeah, okay, so there's some more questions. Where is this list of programs? Sorry, Mark, I don't know what the anaphora of list of programs is for. Yeah, okay. So for everybody else, I'll hang out and troll the Q&A in the chat. Okay, maybe Mark was thinking about the list of programs for Python and mass spec, or the list of programs for like microRNA analysis. I will refer you to Olga to maybe put the right links to some of the other programs that we chatted about throughout the last week and a half, 2 weeks in the May Institute for
maybe
mass
I can
spec.
give my perspective on R versus Python specifically for
Yeah.
mass spec. Sorry, I changed my setup. I don't have the video. But essentially, both are very good and both are very useful. So it really depends on your purpose. It depends in large part on the ecosystem that you rely on. So for our lab, because we do things which are mostly statistical in nature, there's a lot of statistical libraries that we can leverage for what we do in R, so that R is useful for us. Also, R has really good data visualization capabilities. So that's also very helpful. On the other hand, for all things deep learning, Python definitely has much better ecosystem than R. And so newer tools, especially for processing raw mass spec, like doing spectral libraries, Diane and like all of that, this is clearly Python based. I would also say that Python probably is better designed for like pure like software development, because R was not designed for that primarily, but that's a matter of preference, I would say. But in our lab, we are bilingual, we use both, and it really depends on what type of ecosystem we want to leverage for a specific project.
It's also the case that most modern programming languages, including both Python and R, have ways to interface with other languages and use the code that's written in them in a very native looking way. So
well, actually, this is very much true. So some of the projects in our lab, they will call some other language underneath, and the user would not even realize that they're working with a different language.
I mean, in fact, if you're using like the numerical packages in Python, you're using like Lua and you're using COBOL and like some of these like archaic languages that are super powerful, and you don't even know it because it's sort of wrapped and packaged really nicely. In fact, like some of the stuff that we're working on with Jeremy together, we're wrapping like our code in Python to run some of these different analyses, like with the causal inference. Okay, so yeah, let's leave it at that. Let's take 20 minutes and let's start again at 15 minutes before the hour. So East Coast time, that's going to be 12:45. Germany time, that's going to be 18:45. Does that sound all right for everybody?
Sounds good.
If 20 minutes is too long, we can all just chat in the chat. And yeah, so take your time. I'm going to leave the video off in the meantime. So enjoy your break. All right. We ready?
Yep.
Good. Next time we do a full rendition of the bossa nova in the middle instead of just a late jam. Okay, so let's say raise your hand if you're back. Okay, not bad. So I better screen share again. All right, where we left off, we were not checking Slack, right? We had just gone through and checked out our first Tox configuration. And yeah, I think by now we've looked through all of these different files and realized there's lots of hidden stuff there. We're not going to talk about everything and all of them, but we'll get through maybe the most interesting bits. So yeah, before the break, we basically got as far as getting our code in and testing it. Now, why don't we start going through some of this other configuration, just explaining what it is and how it's useful. The first thing that I think everybody can immediately benefit from is this next command, 2 commands down, linting. Hold on, I'm going to close my windows since it's starting to get a little bit rainy here. So yeah, we've got the lint command. Now, one of the problems that a lot of people have who are programming for their first time, maybe while they're studying, or they've never really programmed with other people, is they never thought about how their code actually looks. And so, you know, I think by default, I am writing code that looks like very standardized, but, you know, it's not always the case. Sometimes code has all sorts of weird inconsistencies in it. And maybe there's some like funny spacing. Question already. Oh, was that a question, or you just raise your hand? Okay, just write in the chat if you've got something, or put it in the Q&A. Yeah, so a lot of people are like writing code and maybe it's got some kind of funny spacing. And when you look at other people's code that has funny spacing in it, it makes me want to rip my eyes out because it's really tough to look at. The good news is there's basically a program that rewrites your code for you and puts the spacing in the right places, or it doesn't rewrite your code, it reformats it. So that program is called Black. And so basically we're going to go back to the command line. So by the way, notice that there's now some kind of funny spacing and this doesn't look so great. So I'm going to go back to the command line and I'm going to run tox -e lint. So remember, the thing you put after -e picks the environment it's going to run. So let's jump back here. Here's our lint environment. It's going to install black and isort as its dependencies, and then it's going to run some commands. So let's just let's do that. All right, note that it says, hey, I reformatted some of your code for you. Thanks. So how does this look now? Let's go back, and you can see it fixed all of that funny spacing. So this is great. Everybody should use this all the time for all of their code. It's guaranteed that the code still does exactly the same thing, like because it checks that Python parses it into the same abstract syntax tree, but it puts it into a much nicer looking format. You know, it also normalizes all of the single quotes into double quotes. It just does a lot of really nice stuff. So like everyone should just apply this to their code wholesale all the time. It's going to make it much easier for other people to read your code because it looks more standard in its style. And it's surprising how much extra effort you have to put when you're trying to look past some stuff that's disorganized in the way it's spaced. So yeah, now you can, when you're putting your code into here, you can just run this Tox environment for linting. And if you never heard the word linting before, it comes from like, if you have a cat or something and you take this piece of this roller with some tape and you kind of put it on your shirt to pull all the little bits of cat hair off. This is called a lint roller. And so linting is the act of cleaning your code, the same way that you've rolled the cat hair off of your shirt. So use this all the time. The other part to this, there's black. So let's jump back. There's this black command that does the reformatting of the code. Isort is the import sorter. So we don't have a ton of imports. Let's go back up to the top. There's no imports in this file, but if you had some, it would make sure they're in sort of a consistent alphabetically sorted order. And again, it's just super nice to have this done for you automatically, so you never have to think about this again. All right, let's just start the train of going down here and checking everything. So next one, the manifest. Let's skip that one. This one's really complicated. All right, next one's Flake 8. This one's kind of difficult. So there is making sure that your code has a consistent format, and then Flake 8 is sort of the next level way of checking your code to see if it has like certain qualities to it, like documentation's written nicely. Remember back in the beginning, I mentioned we should write our documentation using the imperative mode. Well, Flake 8 actually can check for that kind of stuff. So you can get reminded, hey, I forgot to do something. Yeah, this one checks to make sure that you've got documentation. Maybe it checks that you didn't use bad variable names that are like one letter. This is not good. How can you invoke black? I just showed you that you can invoke black through Tox. Otherwise, you can just run black as a command line tool. But again, I can show you. So this like tox-e went runs black. That's it. So let's say it's 5. Okay, so yeah, Flake 8 does some of these other checks. We can run Flake 8 with tox-e Flake 8. And let's see, it's going to check all sorts of things and give us some feedback. Now, some of this stuff's kind of nitpicky, and it's kind of a pain in the beginning when it's yelling at you like, oh, you forgot to write a doc string in a class, and you forgot to write it in a method. Oh, you're using assert. Maybe you should like not do that. This kind of stuff. But as you like see this stuff, it gives you some good ideas. You can always comment out stuff that you don't really care to check. Next one, Flake 8 gets you that. Pyroma. This one kind of is useful because what Pyroma does is it checks to make sure you didn't forget anything in the setup.cfg file. So we can run tox-e Pyroma. And yeah, it checks to make sure that you've included author information, license information. It checks to make sure you put enough keywords. And at the end, it gives you a rating out of 10. And it tells you, okay, so I have to explain a little bit of joke, but it gives you a rating of what kind of cheese your package would be if it were a cheese. So funny sidebar, the Python programming language was invented by Guido van Rossum, who's a Dutch guy now working in the United States. And there's all sorts of references to Dutch stuff and also to Monty Python, which is a British comedy sketch group. And so the name Python actually comes from Monty Python. But the name for the package repository, PyPI, the Python package index, was sort of informally called the cheese shop for a long time, like a Dutch cheese shop. If you've ever been in Netherlands, it's kind of fun to go and check out. They have these proper big wheels of cheese. And so packages in the cheese shop are called wheels. Maybe you've noticed this, a couple of times, like getting metadata for wheel. So this is like kind of one of the funny names that they use for this. And so, yeah, that's why we're calling our package a certain kind of cheese. So if you've ever had mascarpone cheese, it's really good. It's almost like creamy. Yeah, so if you've learned nothing else today, you've learned the joke about the cheese shop. Okay, so yeah, we can run Pyroma, and actually this one's not super important if you're using the template because it's already got all the information that it needs when you create the template. So that's one more done. Let's go back to our talks.ini. Here's MyPy. This is pretty advanced. I don't think anyone really needs to worry about this one. This has to do with the type checking that I mentioned with these type annotations earlier. So if you want to know more about that, definitely follow up by Googling MyPy. You can learn a little bit about static type checking. All right, next one is the next bits are about documentation. So I guess we're going to take a break from going to talks.ini and talk about documentation. So let's go back to our API. We've already written some nice doc strings. So the question is, how do we make a beautiful website out of our documentation that's inside our function? And the answer is pretty simple. We are going to look in a different part of the package we haven't looked at yet. So here is our docs folder, already prepared for us, ready to go. It's already got a format for us. It's got the index, and the index has the information about, okay, well, first it says, hey, look, we made this with a cookie cutter, and here's the list of all the things inside the cookie cutter and what they do. But then it creates a table of contents. So if we want to build the documentation, we can go back and we can run talks-e docs. So let's go back to the talks file while it's building. I know we're jumping around a lot. Sorry, this is just how I do this. So here we go. Here's how the docs works. First of all, it installs the docs extra. Remember when we set up .cfg and we had this whole list of things that we need to help build the documentation. Then we are going to build a documentation just using this long, complicated command. No need for you to remember this. All you have to do is remember talks-e docs, and it builds the documentation locally. So let's go back and look at that. It's already done building, and it says, hey, the HTML pages are in docs/build/HTML. So here we go. We're going to open docs build HTML, and it's going to have an index.html. Like most websites, there's an index page. So let's open that up. Here we go. We've got beautiful documentation following the same format that you've probably seen in a lot of Python packages before. This is the read the docs format. And so here we go. We've got some information about the cookie cutter. If we scroll down, we've got the table of contents. So it already has some documentation on how to install this code. So we haven't pushed it to PyPI yet. That's kind of the thing that we do at the end. But you can use pip install to install your code directly from GitHub. This has some instructions to remind you, like this is how you use Git to clone it, and then how you use pip to install it. Question from Lisa. Do you want to write in the chat or write something in the Q&A? Just saw your hand was raised. Okay, but I'll move on, and then we can come back to that whenever you're done writing it. Okay, so then we've got usage, and look at that. It's already set up to take all the stuff that's inside the API file and to just stick the documentation in here. So check it out. We've got our doc string, like our one line that explains what it does. We've got the list of the parameters and the types for each parameter. And then we've got the return information. And look at that. We've also got our example usage. So we're already in a great shape. All the code that we put in this API is just going to get stuck here. And yeah, and if we write good documentation, it might be useful for somebody else. So let's see what this happens. Okay. Good. So I thought documentation was going to take a lot longer, but this actually went quite fast because we've already got this cookie cutter template prepared for us. And, you know, there's some more complicated things you can do with all of these, obviously. I'm just giving you sort of the superficial look at each one. You can see you can add more of these files that can contain different things. You can write narrative text. It doesn't just have to be code. Let's go into this usage.rst. There's also these kind of, so this is using the restructured text format, which maybe is also something you're not aware of. And so, yeah, I would say just look this up and learn about it on your own time. But it has some really interesting stuff that's specific for Python that helps you with automatically turning modules like the simple resolver.api module. So by the way, we call Python files that are inside a package modules or sub modules. So it takes all the stuff inside the API module and then it documents it here. And then we get this, usage, code, documentation. And also you can click on this and see the source code. This is kind of cool too. Okay. So yeah, that's how you write documentation. You just write the documentation inside the code, and then the package has kind of configured everything already to take care of like turning it into these websites. So you can put more of these restructured text files. You can put in the index. You can kind of come down here and add them to the table of contents. There's a lot to learn about Sphinx, to be honest. It's kind of confusing. So having this template is quite nice. And then all the configurations like inside this conf.py file. So again, it's got a lot of black magic inside it. You don't need to necessarily know how it works. Just use it. Okay, so that's docs. So back to talks.ini. So we've got this command that builds the docs. Actually, we've got this other command called docs test. This is kind of interesting. So you can run talks-e docs test, and this runs the documentation builds with a little bit more of a careful eye, and it makes sure that there's no typos, and it makes sure that you didn't put any mistakes like invalid restructured text. How do you deploy this? Okay. Mark, I'm going to come back to this question about how to deploy this to an actual website in a couple minutes, but that's a really good question. Yeah, all right. So so it looks like there were no issues. So nothing to demonstrate here. But anyway, that's just another thing that's kind of built in. Okay, we're going to skip that one. We're going to skip. So doc 8 and doc string coverage also just do more checks on your doc strings to make sure that you remember to write documentation everywhere. So, it's kind of like your friend who's always nagging you, but they just want the best for you. They want you to write good code. Okay, so what else is in here? We said we're going to skip MyPy, doc 8, and doc string coverage. All right, I want to show you something else called continuous integration, which is sort of a really highbrow sort of programmer thing, but it's already set up. So basically, we've got this Tox thing going for us. It's really easy to run all of these commands that are kind of pre-configured for you based on this template. So you really don't have to know a ton about each of them. But now the question is, can we have somebody else run them for us? So every time that we make some commits, we're going to check all of these things. So let's go back to the internet really quick. So cthoy simple resolver. So you can see on GitHub, when you make commits, it sort of lists the last change that you made here. So the last time I pushed the code, it was to initialize the package. You can see over here on the right, there's this little checkbox. And it turns out that that checkbox corresponds to it ran all of these Tox environments and all of them passed. So again, what does that mean? Let's look into one of these. Let's click on details. So did all this crazy stuff, and it basically ran some of these. It checks the manifest. I know I didn't talk about this earlier. Then it checks flake 8, and it ran that flake 8 command with tox-e manifest and tox-e flake 8. And then it runs pyroma for you, tox-e pyroma. And then it runs, static type checking. So again, we didn't talk about that one. But yeah, so basically, there's another part of the repository. Now I'm going to show you how this is configured. There is this folder called .github. And inside this folder .github, there is a folder called workflows. And inside that folder, there is a configuration for how do we get GitHub to run all of our tests, our unit tests, our documentation tests, our checks to make sure the documentation builds properly. How do we get GitHub to run all of these every time we make a change? So it can tell us, hey, maybe there's something wrong with your code, or there's something wrong with the documentation builds because of a typo or something like that. Well, this is the configuration. So really quick, this is in a YAML format. I know we're talking about tons of different file formats, but anyway, we've got some stuff that says, here's the name of this configuration. This tells us when should this test get run. And so it should get run anytime someone pushes code or makes a pull request of code to the main branch, which is just the default one. And then there's a couple different jobs. There's linting, there's docs, and there's tests. So let's look at linting first. So this is the lint job. It runs on the Linux operating system, like a variant of Linux. And then it's going to actually run it on different versions of Python to make sure that you didn't write some code that's not compatible with a wide variety of Python, because that happens sometimes. And then there's some steps. Basically, it checks out the code. So we don't have to understand how any of this stuff works. And then it sets up Python, and then it installs the dependencies, right? Pip install tox. Remember, we did this ourselves maybe an hour ago. And then it runs tox-e manifest, and then it runs tox-e flake8 and tox-e whatever. It just keeps doing this. And so this is for the linting, but it's basically the same for the documentation. It installs tox, it runs all these things. And then again, one more time for the tests, it runs pip install tox and then tox-e py, and the other parts you don't need to specifically look into. But anyway, because all this configuration is there, because we've put such a high level interface into running all of these parts, so GitHub basically does it for us. And that's how we get all of these. And so the documentation, the tests, everything looks like it's working great. And so typically what you want to do is you want to write code in a way such that you keep passing the tests. And when the tests start failing, it's a reminder that you should make some improvements. It's a lot easier to start a project from scratch and then say, hey, I'm already passing all these difficult tests. I'm going to keep passing them. It's much more difficult to take code that already exists and say, yeah, I'm going to have to go back and, improve all this stuff that exists already, right? For example, if you're a scientist, if you're a student, you don't have the incentives to go back and fix old code most of the time. You're not getting paid to do that. You're not going to graduate by fixing your old code. So we have to recognize that there's a huge amount of conflicting incentives. What does it take to do good science and useful science versus what does it take to make a publication versus what does it take to graduate, which is actually what everybody wants to do. And yeah, I wouldn't fault anybody for trying to graduate as fast as possible. So you have to think about all these things. I know there are a lot of big concepts now, but anyway, when you use this package format, all this stuff is there. And so now you have the chance. So this is called GitHub Actions, by the way. And if you want to learn more about how to set up your own tools that run every time you make a commit, you can look into GitHub Actions. And so that's going to bring me back to what Mark asked a couple minutes ago. We were looking at the documentation build, and Mark said, with this HTML, how can I deploy it, in quotes, as an actual website? And so let's look at another package, which I'm going to, oops, hold on. Let's look at another repository that I spend a lot of time working on in my day job, called the bioregistry. And so this is a package that basically has the same format as the one that I've been discussing. As I come up with interesting new ideas in my day job writing code, I put them back into this template so other people can reuse it. And so another action that happens every time I make a commit is that this gets deployed to a website. The documentation is built and put on a website called Read the Docs. So if we go to bioregistry.readthedocs.io, we'll see, hey, look, the same sort of thing is now on this website. And so the question is, how do we get from running tox-e docs to here's this website that actually has it, and it's living on the internet for us, and we don't have to do anything. It just gets updated every time we change our code. So the step in between is we actually go to the website readthedocs.org. And yeah, this is a great website. This is hosted for free for the most part. You don't have to pay anything for it. Obviously, they ask people to make donations sometimes, and they run a couple ads. But for the most part, you can basically just sign in using your GitHub account. And then you can go to My Projects, and you can say import a project. And basically, you follow the import tutorial. It's just it asks you 2 questions. What's the name of the project, and then what do you want the slug to be inside our website, right? Because this is bioregistry.readthedocs. So they ask you, what do you want in front of read the docs? And then it says, hey, I see that you've got this standard package template there. You're all done. So then this happens, because you've got a standard package template, the docs are in the place that it expects, and it has this, setup that's basically standard. It happens. It's quite magic. In the background, so we can look at actually what Read the Docs does. And each, oh boy, that's a lot. So we can see every time you make a push, read the docs knows that you made a push, and then it rebuilds those documentations. So I'm going to very quickly look into one of these builds. And so like it clones the stuff from your repository. So you can see like here's github.com/biopragmatics/bioregistry, the name of the repository on GitHub. And then it like, it does some Git stuff, whatever. And then it makes a virtual environment. We don't have to care about that. And then it runs, it runs Python pip install something. Okay, so it installs some boilerplate stuff, and then it installs all of the stuff that we say that read the docs needs to install it, and then it runs this Python file that has the configuration, and then it like runs the build the same way that we expect it to. So yeah, all this is super easy. So you just go and read the docs and you hook it up to your repository that has the standard template, and then it does this. So one other thing, one comment on that is you need this sort of docs folder that has this conf.py file in it. And then the other thing that you need is this .readthedocs.yaml file. And this just has a very tiny amount of configuration for read the docs. So very quickly, this version says what the version of the configuration file is, like, so we don't have to touch that. This thing says like, use like the most recent Python versions. So then we actually say, okay, what Python versions do you want? So we want 3.8. You can change this to whichever one you want. 3.10 is the newest. And then how do we install it? We use pip. And then we use dot. Remember, pip install dot, so we can install it. And do we need any extras? Sure. Let's list all of the extra requirements we need. They're inside the setup.config file. Remember, we talked about that before. Let's jump back. And here's our docs entry that has Sphinx RTD theme, Sphinx clicks, Sphinx blah, 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 blah. And then, yeah, it installs all those. And it builds it the same way that we were building it with docs. So that is a question answered. I marked that as answer live. Thanks for asking, Mark. That was a great one. And yeah, so there's a couple of ways you can think about this as a scientist. The documentation is a place where you can write code that explains why you did stuff. You can write text and prose that explains why you did things and why did you develop this code and why did you write it. You can write documentation that explains like how to use the code, like from a very high level perspective. I'm sure you benefited from this kind of thing. Like, for example, there was a tutorial on Match MS that I think Mark shared. And so I read that tutorial very quickly during the break, and it looked like, yeah, very high level. So it's like, you want to solve this problem, like import this code, use it this way. And then you can also write like reference documentation, like here's every function inside my package, here's how all of them work, which is a little bit different than like, I've got a purpose in mind. So let's say there's in my ultimate list of Python tutorials, one of the videos on that was by a guy named Daniel Procida, who is given sort of the seminal talk on how to write good documentation, not just writing the docs inside the doc strings like we did, but how to make it useful for other people. And so I would suggest checking out that video. When we're done, I'll go and I'll double check which one that is, and I'll send the link to that specifically in the chat. Okay, so we're kind of getting there, right? So let's take a look. We've basically looked at everything, most of the stuff inside the source folder. We've looked at everything inside tests. We've looked at readthedocs.yaml. We've looked at license. We've looked at the README. Well, not so much, but README is a README. We looked at the setup.cfg. We looked at talks. We're basically at the end. We're almost done looking at everything. And I think I've got maybe 45 minutes or an hour left. So I'm gonna now try to finish up as fast as possible and then allow you guys to ask questions and come back and I can try and backfill some stuff that maybe I glossed over or maybe was a little confusing the first time. So let me gloss over again a couple more things. So here's the manifest file. I want to explain what this is very quickly because this is maybe the scariest sounding one of all of them in my opinion. What the manifest does is it lists all of the folders inside the repository. So like the source folder, the tests folder, some of these like the docs folder. Basically manifest says, hey, when you send this code as a package to somebody else, like when I put this code onto PyPI, the package index, here's all the files inside it that I want to go inside that package. And here's all the files that I don't think people need. So for example, if you want to install this code for simple resolver from PyPI, let's say I put it on PyPI, you don't actually need the talks.ini file. You don't need the configuration files for read the docs. So we say like, let's exclude those. I'm not going to go into more detail on why some of the choices are here and what all these like kind of cryptic looking files are. But anyway, that's the point of the manifest. And this is really useful for a lot of reasons. And in some places it's actually required. So again, we benefit from the fact that this is inside a template and like it's already set up the right way to work with this template. So you can either, I guess the way I'm giving the tutorial today is mostly like you can use this template for like everything you want. Other ways I've given this tutorial is building it up like from zero and then showing each of these parts, but that takes like 3 or more hours. So we don't have time for that. Yeah, but you can always, learn more about each of these parts and try and configure them yourselves. But for the most part, using stuff out of the box works great. Okay, what's left? What's left? I skipped over versioning. Okay, why don't I do versioning? So remember we started with our code is at version 0.0.1-dev. And now we're looking at this bump version.configuration. Got another configuration file, right? It's like, how are you ever going to remember all this stuff? So anyway, at some point, you want to probably like say that the version is increased. And so rather than like going and editing the text for like what the version is, I've provided another Tox environment for you. So this one's called bump version. Okay, here we go. So typically the way that this works is you would say, all right, my stuff is done. So I want to now do like bump version, and then I want to release. So if I do this, let's double check this isn't going to work. Okay, so I have to make a commit first. So let's add. I didn't do a very good job doing the thing I said I would in the beginning, where I was going to make all the changes one at a time with the commit. So let's just updates from before the break. This isn't a good commit message. Please do better than I did. So anyway, let's come back and let's go to Tox. And if we want to do bump version release, we can basically run this command, and then it updates this version string in all the places where it needs to. And there's 3 places where this version string shows up: in the like configuration for the versioning system, in the configuration for the documentations, and also in the configuration for the code itself. So yeah, this is probably the most confusing thing that I've talked about so far. So this is sort of the system for doing that. And what happens when you run this function bump version release is it like makes a commit where it goes through and it finds all the files that have your version with like 0.0.1-dev, and then like takes the dev part off of it. And so yeah, and then you have like, this is the version, and it also adds a tag. So on Git, it says like, hey, look, this is version 0.0.0.1. All right, I'm really tempted to continue to gloss over this one because I think this whole versioning thing is kind of complicated. And for the most part, you're not going to do that a lot with your scientific code. So let's think about something a little bit different. So let me double check if we've got test release. Yeah, test release. Okay. Yeah, the last thing I want to mention before we like finish is how do you put this code on PyPI so other people can download it? And so there's a couple commands that you basically have to run. And so I want to kind of look through all those parts of the, and you don't have to remember these, you just have to remember that there's sort of environments in the Tox file to do this. And so the first thing is like, you should build your code into a package, like that's, one file, like a zip file. And so basically you use this package called the build package. And then you say, hey, build package, like take my code, which is in a standard format using a standard set of configuration, and like package it for me. Then the next step is the release environment, where you say, hey, I just built all my code into a standard package. Can you take that package and upload it to PyPI, the Python package index, so other people can pip install it? Yeah, and that's it. Like once you do that, your code's out there and people can pip install it. So there's sort of 2 other parts to this that I like to do. So basically, I usually like to bump my version, like take that -dev thing off. And then I like to build the code, and then I push it to PyPI, and then I bump the version again to the next version up, and then have it like, so I go from like 0.0.1 dev, then to 0.0.0.1, that's the release. Do this build and release thing to PyPI, and then want to bump the version again to 0.0.2-dev, the next version, but it's like the development version. And so that's confusing, and explaining all that's kind of hard. So basically there's the ultimate workflow, tox-e finish. And so if you type tox-e finish, it will take your code, it will do all the things I just described, so you don't have to remember, and then it will push it to PyPI, it'll do all the commits to Git for you, and then it bumps the version. So this is the workflow that I use, and I hit enter if I wanted to put simple resolver onto PyPI. But at the moment, I don't want to push this to PyPI because it's not really doing anything, and PyPI, is a free service, and it's sort of rude to the community to put trash on it. So this isn't like a really well thought out package. So I'm not going to push this to PyPI. But anyway, that's the place where you end, is tox-e finish. So yeah, now we've kind of gone from the beginning to full speed. We talked about how to use this template and how to set it up. We talked about all the parts inside it, from the way you organize your code to the way that you import the code, and then to creating tests, to creating documentation, all of these other quality assurance tools, and even the tools that run all of these, like Tox, that makes them reproducible. And on top of Tox, the continuous integration system, which is built into GitHub, that runs it for you every time you make changes. And then on top of that, we've figured out all these different tools that are built into this package template that help you to put your code onto PyPI in case you want to make other people able to use it. Now, it's not a strict requirement that people should be able to pip install your code to make it useful. But let's say that you've come up with an algorithm and you want somebody to be able to use it. It's nice if they can just import it directly, and if they can include your package in their list of requirements, the same way that you use NumPy. So that's it. I think it's a good place to stop there. We've got a little bit more than 40 minutes. You've been listening to me talk for 2.5 hours straight now. So kudos on you. It's now time, I think, to open it up to questions. Please, anybody who wants to come on voice chat or on the video, we promote you to speakers. Otherwise, we can just chat in the chat or on the Q&A system. So yeah, thanks for listening. I'll give a proper valediction when we're really all done. But does anyone have any questions, like this, even anything related to Python packaging or even Python programming? I'd be happy to answer some stuff to help you get started. If I didn't really ask ahead of time what's everybody's Python level or how familiar are you with programming. But like, if you want some other resources, this is probably a good time for me to go and find all the things that I said I'd send to you and make sure that you've got those. Yeah, and anyone can ask for something. For example, I can give you all my contact information, right? So here's I'm gonna put my email in the chat. You can like Twitter me with CT Hoyt. You can like find me on GitHub. How else do people try and get in touch? You can stand on the side of a mountain and yell at the top of your lungs, and I might hear it, but no guarantees. How else do people talk to each other? I think these are pretty reasonable ways of getting in touch. Yes, if it's a German mountain, you can hear me. If does Germany have any mountains? I mean, I'm from New England, right? So like, we've got better mountains in New England. I mean, I know Germany has mountains. I was just kidding. Yeah. So thanks for listening. Please, let's chat now in the chat. I'm going to stop sharing for a second, but I can do screen share again if we need to. So maybe like a show of hands, who's still here, or who like can actively participate. Nice. Okay. Yeah. So does anybody want me to like allow them to talk? Can I just do that to everybody? Sarah, can I pick on you?
Yeah, sure.
Did you learn something today?
I couldn't follow exactly all the steps that you did today, but overall, I had a great overview of what reproducible programming looks like, and what I as a researcher need to do, and what I was missing for a long time during all these years of research, and what I can do for my follow-up research that I'm definitely gonna do. So definitely valuable information for me today.
That's good. So yeah, again, this is the first time that I gave this talk with like the perspective of the template. So I kind of felt like I may have harped on a couple like nonsensically specific details, like maybe some of the things that I showed were not super useful for you, or like very specific. But yeah, I think, you know, learning all this stuff, I mean, it's taken me years to like read about all of them, and it's not like it's the most accessible kind of thing. So, you know, everyone can try looking over the video again. It's gonna be on YouTube. And yeah, so you can always ask me questions. Like I just put all my contact information if you want clarifications on certain bits.
Yeah, great. I definitely need to rewatch the video to like remember the like specific steps.
I would say like maybe the best way to do a follow-up to what we talked about today here is try downloading that cookie cutter package. Use you know, pip install cookie cutter, and then run the cookie cutter program to actually get the template, and then try putting your own code in it if you've got some Python code that you've written. And then, you know, I think maybe something that we could have done, which would have required a lot of planning, so I didn't quite make it, would be like if you, for example, write a lot of code in Jupyter notebooks, which I think a lot of us do, right?
Exactly.
Even if your science labs, and by the way, even if you're programming in like R, you might still be using Jupyter notebooks. And so typically you have some data that you load into the notebook, you do some stuff on it, you iterate over like writing code this way, that way, you look into the data. You know, and the way that you think about writing a Jupyter notebook is actually kind of different from writing reproducible and reusable code. Like definitely a problem that we've had, like Sarah and I have written code together before. And sometimes we write code where you run the notebook out of order. And so one of the cells on the bottom has to get run before one of the cells on the top. And this just happens like completely organically because of how we, you know, think and do our coding. And then if somebody looks at this after, like they don't know that you did that. And so like maybe a good thing for everyone to try is find a Jupyter notebook that you wrote something in Python, and try taking the parts of that Jupyter notebook, like one bit at a time, putting it into function, putting it into just maybe like a single function, like a def main. See if you can figure out how to get all that into a single function inside this package. And then like, you know, import that from somewhere else, and then think about like, how do I specify the path to the file rather than hard coding a path on my file system. Actually, you know what, one of the things we didn't chat about was the command line interface and thinking about that. And maybe that would have been more valuable than some of the other things. But to be honest, I forgot about it until this very moment. There's so many different parts to these packages. Maybe doing it in a 1 3-hour block just like melts everyone's brains too. So anyway, thanks for like listening for so long too. So yeah, that could be a great way to follow up is to do this in practice. You know, so a lot of this Python programming stuff. I mean, when I was learning how to program, I couldn't just sit down and like read tutorials like, and this is how the for loop works, and this is how the with statement works. Like, I don't care about that stuff. It was like when I had real problems I wanted to solve, I would find the stuff I needed to solve the problems, and then I would like know about it a little bit, and then later, you know, you kind of backfill some of the like the theoretical parts, like, hey, why does that part of the Python programming language kind of work that way? Or like, were there some secret sneaky things I didn't know about? Like then you can learn about that after.
I have a question about like the size of the project. So for example, sometimes we have an algorithm that in the paper it has a theory and it's really important that we have an implementation for that algorithm that other researcher can use of. But sometimes the research is on some small simulations like toy examples, something that doesn't necessarily have an algorithm associated with it, but it's just some simulations to get some results, and we may even put those results in the paper. But is it worth to like create a package for those kinds of simulation when it's like it can be reproducible, so you can run the simulation again and get exactly the same result, but it's not an algorithm where you do you know what I mean?
I think yeah, and like so Sarah and I have collaborated together before for everybody else, like just so you know, and we've had this like situation happen a couple times, and maybe the perspective that I have is a little bit different, and so like if it's totally valuable to come up with small toy examples to demonstrate a thought process. But actually an algorithm is like sort of a way of implementing a process. And so, you know, you can still implement the algorithm that can be run on a small toy data set. And it should, and ideally algorithms can work on small toy data sets and also on potentially more interesting big data sets that are more real world. And so if you've kind of come up with the algorithm, providing an implementation of the algorithm, like in this automated way, is a little bit different from like, let's say you maybe this example, we created like a simulation and, you know, it assigned some variables, some values, and then it did some math on them. And it, you know, did this like this estimation of the mean and the variance of them, like just a very high level, like simple version of it. Like this is something we did. And this was kind of like, you know, parts of it were hard coded and by hand, and they used like a specific language for doing these simulations. And so like, this is a little bit different. That kind of thing isn't what really fits inside a package. But if you know, implement the algorithm that's sort of more general, then this is valuable as a package. So ideally, everybody, even for small examples, implements an algorithm that someone can reuse. But we know that's not really the case for all sorts of reasons. Perhaps it's because not everybody knows how to write packaged code. But in some cases, it's also like difficult to go from sort of handcrafted simulations and examples to really more general algorithms. So
Yeah.
Again, it's about using your best judgment. You know, I'm a hardliner, and you know,
I know. Yeah.
package all code, even the simplest stuff. But you know, there's all practical considerations, like I mentioned, the trifecta of like doing useful science versus like finishing your PhD.
Right. Makes sense. Thank you, Charlie.
Okay, so Vardika asked in the chat, any advice on documentation for Jupyter notebooks? So if everyone is not, I hope everyone's familiar with Jupyter notebooks, but these are kind of like this thing I was doing inside the command line where I was importing some Python code and then like interactively running it. Jupyter notebooks like that on steroids, like more powerful version of that, where you can have blocks of code that get run together and it's interactive. And Jupyter notebook also allow you to stick cells that are marked down documentation. Now, another hardline opinion from me is I actually hate Jupyter notebooks. I think that they're sort of misused. And like this scenario I described earlier, where you're creating ideas and you're iterating over stuff. I think that's what Jupyter notebooks are good for. But when you, let's say when you publish a paper and you're like, and then our analysis was done in this Jupyter notebook. Well, it's not like reproducible necessarily because you don't know how it got run or like what kind of thing. I would say that's why you want to take code out of it and put it into Python packages. But anyway, that's not the answer to your question, Vardika. The answer to the question is like you can put markdown cells in between the actual code blocks to give high level descriptions of what's going on and why. And then I would suggest inside your Jupyter notebooks, actually creating functions that do the things that you want to do. And then later you apply those functions, even in the same notebook. And then you can think about writing the doc strings inside those functions that describe not the high level stuff, but the specifics of like, how is it being done? And then once you've done this, you can think about like porting that code out of your Jupyter notebook into a package, and then using the Jupyter notebook to import that package. I know that some of this is a little bit tricky too, and we glossed over like many things, like doing this installation and then making sure they're all available in the same environment, but like you can make that work.
Right, so like I was thinking more of as a tutorial, like if you've made your package, then you want to make a tutorial and like Jupyter notebook to show it. Is there some template we should follow for it, or just like, as you said, adding markdowns and going ahead with it?
I think that you can, when you want to give tutorials, there's no rules, but tutorials that are useful kind of help the person who's reading them think about like, why am I solving this problem? Actually, let me just go ahead and find that Daniel Procida talk right now, because I cannot explain better than this guy why you should, how to write documentation, and highly suggest that everybody watches that one. And unlike my presentation, which was 2.5 hours, his is only 25 minutes. So you can watch it at double speed and, and have a much nicer time, I hope. So I'm going to find that video for you right now. All right, so. Yeah, and then if you want to know more, like just search for this guy's name. His name's in the title, and then you can find more about like him talking about this, and it's so worth it. All right, so good. Anybody else have any stuff? Like, what are y'all working on? Mass spec, proteomics. You go in and digesting some proteins in the lab. I like mass spec. I enjoy doing that. It's been a while though. Or are you guys doing like omics analysis? I'm just curious. Just write in the chat. All right, if no one wants to write in the chat, I guess it's time to wrap up. So final wrap up, you know, today is the last day of the May Institute. And I have the bizarre pleasure to give a valediction to the entire 2-week thing. So I hope everybody enjoyed some other talks besides this one, some stuff about other programming languages like R, some stuff about, you know, mass spec, about other kinds of proteomics analysis. I hope everybody got the chance to learn something new. And yeah, so I wanted to like just end it by thanking Olga one more time for like putting a lot of this stuff together and like, you know, being a cool collaborator. And then all the PhD students and grad students in our team, Vartika, Sarah, welcome to Rohan and some of the other ones I think who've just joined. Yeah, and then thanks to like the Kauri College of Computer Sciences and yeah, I mentioned before like the NIH and Chan Zuckerberg Initiative for like funding this whole thing. I guess it's a good time to wrap it up. So yeah, unless anyone's got any other stuff, thanks. Feel free to get in touch with me on, you know, GitHub, Twitter, email, whatever. And if you don't know how to do that stuff, then just ask Sarah or Vartika to get me in touch with you. Yeah. Oh, so some people are writing some stuff, so I'll take 2 minutes to read it. So yeah, I'm going to end the recording, but we can still stay in here. So thank you. Nice. Okay, yeah, so Silas mentioned in the chat that his Python programming is a little basic at the moment. I'm sure he'll learn more soon. But a lot of the things that we talked about are totally applicable across other languages. And I glossed over, like many things, using Git and GitHub. These are super powerful tools for working on programming, also for collaborating. I know we didn't talk about that a lot, but it really enables people to work together in a really interesting way. So yeah, everything that I talked about today, you just dipped your toes into it. You're going to have to read more about everything, whatever's most important to you. Follow up on that. And yeah, I think that's a good place to end it. It is now Friday afternoon in Germany. It's been raining all day and the sun has just come out. I think it's time to go and sit by the river with a glass of wine. I hope you guys all have a nice afternoon and evening. Thank you very much for listening. Pleasure to talk to you in the chat and you guys who were on The Voice. And yeah, I hope to hear from some of you soon.
Thank you,
Bye-bye.
Charlie. Bye-bye.
Yeah, thanks a lot.